Hello friends, this is Priyanka. Today we are going to solve a problem on Nyquist plot. In this video we are going to understand how to draw the Nyquist plot as well as how to determine the value of k for the stability of the system. So let us first understand what is the given open loop transfer function. G of s h of s is equal to k in the bracket 1 plus 2s divided by s 1 plus s 1 plus s square. Now we will first understand how many open loop poles are there. So to find out the open loop poles, we have to take this denominator is equal to 0. So there are total 3 terms in the form of s. So each of these term is equal to 0. So we can say that s is equal to 0. Then 1 plus s is equal to 0, and that is why s is equal to minus 1. Then we will equate this s square plus s plus 1 is equal to 0. So for this again we have to take the solution for the s. So this is the second order equation. So how to take the roots for this equation? So for that we have formula, that is minus b plus minus under root of b square minus 4ac divided by 2a. Now here a is coefficient of a square, b is coefficient of s, and c is constant. So a is equal to b is equal to c is equal to 1. So if we solve this, then minus b, that is minus 1, plus minus under root of b square minus 4ac, that is 4 divided by 2. So I will again solve this, that is minus half plus minus under root of minus 3 by 2. So minus root minus 1, that is nothing but z. So I will write here minus 0.5 plus minus under root of 3 divided by 2z. So if we observe s is equal to 0, s is equal to minus 1, and s is equal to minus 0.5 plus root 3 by 2z minus 0.5 minus root 3 by 2z. So these are the 4 number of open loop poles. Now if we plot these poles, then here one pole is at origin and other poles are on the left hand side of the S plane. So we can say that all the poles are on the left hand side and no any pole is on the right hand side of the plane. So this is the important statement that we will use in the last step to determine the stability. Now we will understand how to plot the Nyquist contour. So for Nyquist contour, here there are total 4 sections. Now why there are 4 sections? So remember, whenever this pole is at origin, then there are total 4 sections in Nyquist contour that we have to draw. So when this pole at origin does not exist, then there are only 3 sections. Now for this transfer function, which is that extra 4th section, we will understand. Now first section, we will understand the first section. So for this I have to draw here S plane, where this horizontal line is the real axis, this vertical line is the imaginary axis. Now I will highlight the first section. So this is the section 1. So I will give here the arrow. So this section 1 is nothing but C1. So how I will define this section 1? So here if we observe this section will start from this origin, that is 0, and will end towards the infinity. So here is plus infinity is there and here is minus infinity is there. So on this line or on this vertical line, because this is the imaginary axis, here is value of plus j omega, that is here is plus 1, plus 2, plus 3, but in the form of j omega. So to find out its contour, we have to plot s is equal to plus j omega, and whenever we put s is equal to plus j omega, then this plot is known as polar plot. And here omega, varies from 0 to plus infinity. Then how we have decided this? Because this section C1 starts from 0 and ends towards the plus infinity. So this is all about the information for this section C1. So we will use this information, we will apply this information for this transfer function, and we will draw the Nyquist contour for this section C1. Then we will move for the next section, that is the section C2. So I will first highlight this. I will show arrow also. So here this is the section C2. Now if we observe on this vertical line, what is the angle? Plus pi by 2, or we can say plus 90 degree, and here angle is minus pi by 2 or minus 90 degree. Now how we will define this section C2? So this section C2 we will define, that is in terms of capital R e raised to j theta, where R tends to infinity. Now this, what is the meaning of e raised to j theta? So it will be used to calculate the phase angle phi. So here theta varies from this plus 90 degree to minus 90 degree. That is, we can say that theta will vary from plus pi by 2 to minus pi by 2. So this is all about the information for this section C2. So to draw the Nyquist contour, we have to apply this information for this transfer function, and we will find out what is the shape for this section C2. Now we will move for the section C3. So I will again highlight this. I will use arrow also. Now if we observe here, this section C3 is on the imaginary axis, and here all the values are in the form of minus j omega. That is, here minus 1 j omega, minus 2 j omega, and so on. So here we have to put S is equal to minus j omega. So when we put this, we will get the inverse polar plot. So I will use here inverse polar plot. So this polar plot is the mirror image of, this inverse polar plot is the mirror image of this polar plot. And here omega will vary from, now how to decide? So if we observe, here is the minus infinity, and this section C3 move from this minus infinity towards 0. So we will say that omega will vary from minus infinity to 0. So this is all about the section C3. Now we will move for the important section, that is section C4, and we have to take this section C4 only when there is pole at origin. So whenever S is equal to 0, then only we have to add this fourth section. Otherwise we should not add this fourth section. So I will show here. So this is the section, I have shown here arrow also. So this is the small section. Now how we can write about this section C4? So I will write here, for section C4, this is in the form of small r e raised to j theta, and r tends to 0. So this is very small and it is nearby to origin. Here small r tends to 0 and r e raised to j theta. So we have to take here S is equal to r e raised to j theta in this formula, and we will find out the contour for this section C4. Now if we observe, how we can say that this theta will vary? Now here I have shown the arrow in the upward direction. So here the angle is minus pi by 2 and here angle is plus pi by 2. So we can say that here theta will vary from minus pi by 2 to plus pi by 2. So this is all about the section C4. We will apply this information to this transfer function and we will find out the exact Nyquist contour. Now we will move for the first step, that is the mapping of section C1. So for this we have to put S is equal to plus j omega, and omega vary from 0 to plus infinity. Now if I put here g j omega h j omega, which is equal to k 1 plus 2 j omega divided by, we have to take j omega 1 plus j omega, then here 1 plus j omega plus, now a square, that means j square omega square, but we know that j is equal to under root of minus 1 and therefore j square is equal to minus 1. So I will write here instead of j square I will write minus 1 omega square, that is minus omega square. Now again we will simplify this, that is k 1 plus 2j omega divided by j omega 1 plus j omega. Now from this bracket we have to take real part and imaginary part separate. So here 1 minus omega square, so I will write here 1 minus omega square in one bracket and plus remaining imaginary part is here plus j omega. Now we will find out the magnitude as well as phase angle. So here we have to take every j omega term in the square root and we have to take square. So here k we have to take for this j omega term, that is square root of 1 plus 2 j omega. So I will take square root and square simultaneously. So here square root of 1, that is 1 plus 2j omega. So what is the square? That is 4j square omega square. But here j square is equal to minus 1. But here modulus is there. So we can say that modulus of j square is equal to plus 1. So I will write here 4 omega square. So this negative sign is getting cancelled because of modulus. Now here also I have to take square root and square for this j omega. So square root of j square omega square. So again j square is plus 1. So square root of omega square, that is omega. So I will directly write here omega. Then for the next term 1 plus j omega. So square root of 1 plus j omega square. So here I will take square of 1, that is 1 plus j square omega square. So modulus of j square is plus 1. So I will write only omega square. Now for this third term also we have to take here square root and square simultaneously. So here for this real number, that is 1 minus omega square, we will take square 1 minus omega square bracket square plus we will take its square, that is j square omega square. So j square, modulus of j square is plus 1. So I will write omega square only. So this is the magnitude. Now we will move for the phase angle. So I will write here angle g j omega h j omega, which is equal to. Now how to write the angle? So we know that to write the angle we have to take tan inverse of imaginary part by real part. So here this term is in the numerator, so I have to take here what is the imaginary part. So for numerator I will take plus sign, that is plus tan inverse of imaginary part. So imaginary part is 2 omega and real part is 1, so no need to take here, divided by 1. Then for this j omega, so this term is in the denominator. So for this denominator we will take minus sign. So minus tan inverse of omega by, now no any real part, so omega by 0. So omega by 0, that means infinity. And what is the value of tan inverse of infinity? That is 90. But this term is in the denominator, so I will directly write here minus 90. Then we will move for the next. So this term is also in the denominator, so I will write minus tan inverse of imaginary part by real part, that is omega by 1, that is only omega. Now here also for this term, if we refer this simplified form, then again this term is in the denominator, so I will take minus tan inverse of imaginary part. So imaginary part is omega divided by real part. So real part is 1 minus omega square. So this is our phase angle phi. Now we will put here the value of omega, that is omega vary from 0 to infinity. So when omega is equal to 0, then what is the magnitude and what is the phase angle phi, that we have to calculate. And when omega is infinity, omega is equal to infinity, then what is the value of magnitude and phi, that we have to calculate. So omega is equal to 0. So for this magnitude, if I put omega is equal to 0, then here k under root of 1, here whole term becomes 0, here denominator is 0, so here under root of 1, and here this bracket will become 0. So anything divided by 0 is nothing but infinity. So I will write here magnitude is. Now we will put omega is equal to 0 to calculate the phase angle phi. So tan inverse of 0 is 0, tan inverse of 0 is 0, so remaining angle is minus 90 degree. And now when we put omega is equal to infinity, so here k divided by infinity. So constant divided by infinity, that is nothing but 0. So I will write here magnitude 0. Now what about the phase angle phi? So tan inverse of infinity is plus 90 degree. So here plus 90 degree, minus 90 degree, minus tan inverse of infinity minus 90 and minus 90. So this plus 90 minus 90 is getting cancelled. Angle is minus 180 degree. So I will write here phase angle phi, that is minus 180 degree. So this is the S plane, this is real axis and imaginary axis. Now we will take here the angles, that is here 0, then I will write plus 90 plus 180. So how to plot the negative angles, that is we have to move in the reverse direction, 0, minus 90, minus 180 and so on. Now here if we observe, omega varies from 0 to infinity, that is this is the start point and this is the end point. So for this start point, magnitude is infinity, angle is minus 90. So I will draw here along this minus 90 degree angle, here is infinity line. So I have to take, this is the starting, so I will show arrow in the upward direction. Now here is the end is at magnitude 0. So here magnitude is 0 at origin and angle is minus 180. So along this minus angle I have to draw here the plot. So here this is the polar plot. Now we will move for the step 3. Now step 3, that is the inverse polar plot, and that is the mirror image of this polar plot. So we will move from the step 1 towards the step 3, that is the mapping of section C3. So for this section C3, that is the inverse polar plot, and we have to draw the mirror image for this graph. So I will draw here the mirror image. Now we have to show arrow also. Now for this polar plot ends at magnitude 0 and along this minus 180 degree. So we have to take the reverse process, that is we have to take this inverse polar plot, start at magnitude 0 and along this minus 180 degree. So this is the starting point, so I will show arrow in the upward direction. So this is the inverse polar plot for section C3. Now we will move for the step 2, that is the mapping of section 2. So for this section we have to put S is equal to R e raised to z theta, where R tends to infinity and theta will vary from plus 90 degree to minus 90 degree. So instead of 90 degree we can say that pi plus pi by 2 to minus pi by 2 also. Now when we put here g of s, h of s at s is equal to R e raised to z theta, then k 1 plus here 2, we have to write here 2, and instead of s we will write R e raised to z theta divided by R e raised to z theta in the bracket 1 plus R e raised to z theta, in the second bracket 1 plus R e raised to z theta, and for this s square we will write R square e raised to 2z theta. So this is very important term, that is e raised to 2z theta. Now we will take here R e raised to z theta as a common term. Now when R tends to infinity, then we have to take this common term, because when we take this as a common term, then this R e raised to z theta term will move in the denominator, and anything divided by in the denominator instead of R, if we write here infinity, then that whole term will become 0. So this is the reason why for this step, or when r tends to infinity, for this second step we are going to take r e raised to z theta as a common from the each bracket. So remember, when r tends to infinity, then only we have to take this extra step. So here r e raised to z theta is a common. So here 1 divided by r e raised to z theta plus 2, because if I divide for this whole bracket as r e raised to z theta, then this term is getting cancelled. Then we have to write this term r e raised to z theta as it is. Now from this bracket also we will take r e raised to z theta as a common. So this will become r square e raised to 2z theta. And when from this bracket we have to take maximum power, that is r square e raised to 2z theta as a common. So here total will become r raised to 4 e raised to 4z theta. So what will be about these two brackets? So here 1 divided by r e raised to z theta plus 1, and from the second bracket we have taken this as a common term. So we have to divide this term with this all the elements. So 1 divided by r square e raised to 2z theta plus, now here r e raised to z theta and r square divided by r square e raised to 2z theta. So it will become 1 divided by r e raised to z theta, because one power is getting cancelled. So remaining power is only 1. Now plus r square e raised to 2z theta divided by r square e raised to 2z theta, that is plus 1. Now this step is getting completed. Now if we observe, if we put here r is equal to infinity, then this term will become 0. So 0 plus 2, that is 2. Then here if I put r is equal to, for this term if I put r is equal to infinity, then this whole term will become 0. So 0 plus 1, that is 1. And if I put r is equal to infinity, then for this bracket also 0 plus 1, that is 1. So 1 multiplied by 1, that is 1. So here we will take 2k, and here r into e raised to z theta divided by r raised to 4 e raised to 4z theta. So 1 r is getting cancelled. So divided by r cube, and e raised to z theta divided by e raised to 4z theta, that means 1 divided by e raised to 3z theta. So for this e raised to 3z theta from denominator, if I move to the numerator, then it will become e raised to minus 3z theta. So here this indicates magnitude, and this indicates phase angle phi. That is important. Now for this magnitude, if I put value of r, that is infinity, so this constant divided by infinity, so magnitude is 0. Magnitude is equal to 0. And what about this phase angle phi? So this phase angle phi varied from plus pi by 2 to minus pi by 2. So I will write here for this plus pi by 2 towards minus pi by 2. So if I take plus pi by 2, then here what is the angle? That is e raised to minus 3 pi by 2. So I will write e raised to minus 3 pi by 2. And if I take minus pi by 2, then minus minus will become plus, e raised to plus 3 pi by 2. So this is the start, or we can say starting angle from minus 3 pi by 2 towards the plus 3 pi by 2, and here is the end, and magnitude is 0. Now here magnitude is 0, but still I will draw here the circle. So how to draw? So what is the total circle that is getting covered? So this minus 3 pi by 2 means what? So 3 pi by 2, that means 270 degree. So minus 270 degree to plus 270 degree, that is getting, this angle is getting varied. So here what is the total circle covered or total angle covered? We will calculate 270 plus 270, that is equal to 540. 540 divided by 360. So total circle covered is 1.5, that is 1.5 circle is getting covered. Now if we observe here plus pi by 2, 0 plus pi by 2, I will write plus 90 plus 180, and here plus 270 and 0 minus 90 minus 180. Now this circle for 0 magnitude, so I will take radius very small, start at minus 270 degree. So here is the start point, that is here is minus 270 degree. So I have to start here this circle, that is very small circle. Here one round, that is total angle 360 degree is getting covered, but here 1.5. So again we have to draw here half circle, and here at the angle of plus 270 degree it is getting completed. So here is the start point and here is the end point. So I will show arrow also. So this circle is having 0 magnitude. So in the final Nyquist plot we will not show this structure, but this structure is only for the understanding purpose. Now we will move for step 4 because step 3 is already getting completed. Now this step 4 is for mapping of section 4. So for this section we have to put S is equal to small r e raised to z theta, where r tends to 0, and this theta vary from minus 90 to plus 90 degree. Now when we put S is equal to r e raised to z theta for this, then this is the equation k 1 plus 2 r e raised to z theta divided by r e raised to z theta in the bracket 1 plus r e raised to z theta plus in the second bracket 1 plus r e raised to z theta plus r square e raised to 2z theta. Now we have to simplify this. So when we take here r is equal to 0 because r tends to 0, then this whole term will become 0, this term will become 0 and this term will also become 0. So k divided by r e raised to z theta, that is remaining. So if I put r is equal to 0, then k divided by 0, that is infinity, and this e raised to z theta, if I take in the numerator, it will become e raised to minus z theta. So this infinity is nothing but magnitude, and this e raised to minus z theta is nothing but phase angle phi. But here it is given that theta varies from minus 90 to plus 90. So we can say that minus 90 means minus pi by 2 to plus pi by 2. So when I put theta is equal to minus pi by 2, then what is the phase angle phi? That is minus minus will become plus, e raised to plus pi by 2. And when theta is equal to plus pi by 2, then what is the phi? So this plus minus, that is minus e raised to minus pi by 2. So this is the phase angle phi that will vary from plus pi by 2 to minus pi by 2, because this is the start and here is the end. And what about magnitude? Magnitude is infinity. So we have to draw here the Nyquist control for these given conditions. So magnitude is infinity and angle vary from plus 90 to minus 90. So this is real axis, imaginary axis, here is 0, here is plus 90 degree angle, plus 180 degree angle. If I have to take minus sign, then here 0, I have to move in the reverse direction, minus 90 degree, minus 180 degree. Now with magnitude infinity, how I can draw this contour? So here we have to move from plus pi by 2, that is this plus 90 degree, with magnitude infinity to the minus 90 degree. And here how to calculate total angle covered, this 90, that means 180 degree. So total angle covered, that is 180 degree, that means half circle. And I have to take arrow, this is the start point, that is from plus 90 to the towards the minus 90. So this is the Nyquist control for this section 4. Now we will move for this step 5. We will find out the point of intersection of Nyquist plot with real axis. So how to find out this? So for that we have to show imaginary part is equal to 0. So what is the first step? That is we have to put S is equal to j omega. So this is the equation. Now again we will simplify this. So we will separate here the real part and imaginary part. So this is the equation, that is k 1 plus 2j omega divided by j omega 1 plus j omega 1 minus omega square in one bracket plus imaginary part j omega is outside. So this is the equation. Now for this equation we have to take imaginary part is equal to 0. So we have to remove this imaginary part from the denominator. So how to remove? For that we have to multiply the complex conjugate number for these two brackets, and then we will transfer this, that is for the numerator and denominator we will multiply here the complex conjugate. So how to determine this complex conjugate? So here 1 plus j omega is there. So I will multiply and divide here with 1 minus j omega. So this is the real part and this is the imaginary part. So I will say a plus b is here. So I have to multiply with a minus b. So how to multiply? That 1 minus omega square minus j omega. That I have to multiply. So I will take here k 1 plus 2j omega divided by j omega. Now here 1 plus j omega. What is the complex conjugate? 1 minus j omega. Now here 1, now in the second bracket 1 minus omega square plus j omega is there. Now I have to multiply with complex conjugate, that is 1 minus omega square minus j omega, because a is this real part and b is this imaginary part. Now I will take this complex conjugate to the numerator also, so whole effect is getting cancelled. So 1 minus j omega and here 1 minus omega square minus j omega. Now if we observe this is the equation in the form of a plus b, a minus b. So how we can write this? A plus b, a minus b, that is nothing but a square minus b square. So in the denominator we will continue this. So k 1 plus 2j omega 1 minus j omega, in this bracket 1 minus omega square minus j omega divided by. Now this j omega I will write here as it is. So a square minus b square. So a is real number, b is imaginary number. So a square, that means 1 minus, so I will write here 1 minus j square omega square. So j square is nothing but minus 1. So this minus 1 and this minus sign will become plus. So 1 plus omega square I will write here. Now here also I have to take this same term, that is a square minus b square. So a is nothing but 1 minus omega square bracket square minus b square. So minus b square means what? J square omega square, but j square is minus 1. So here plus omega square. Here j, that is the imaginary part in the denominator, so we will transfer this in the numerator, so it will become minus j, and we will also multiply these two brackets, so minus jk. So if we multiply here 1 plus j omega plus 2 omega square, and here we will remove this bracket and we will simplify this, that is 1 minus omega square minus j omega. Now if we observe this denominator, only real numbers are there, that is in terms of omega, no any imaginary part is here. So from this step, if I equate this step is equal to 0, then it will, this denominator is getting transferred to the right hand side and it will become 0. So now we will consider only numerator. So minus jk is outside the bracket and we will multiply these two brackets. So 1 multiplied by 1, that is 1. 1 multiplied by minus omega square minus j omega. Then we will multiply this j omega to this bracket, that is plus j omega, and j omega multiplied by minus omega square, that is minus j omega cube, and j omega multiplied by minus j omega, that is here it will become minus j square omega square, but j square is equal to minus 1, so this minus will become plus, so plus omega square. Now we will multiply this 2 omega square, so 2 omega square multiplied by 1, that is plus 2 omega square. Then here 2 omega square multiplied by minus omega square, that is minus 2 omega raised to 4, and 2 omega square minus j omega, that is minus 2j omega cube. Now again we will simplify this bracket. So here is minus omega square plus omega square, that is getting cancelled. And now this minus j omega plus j omega, that is also getting cancelled. Here minus j omega cube minus 2j omega cube, that is minus 3j omega cube. So what is the remaining? that is 1 plus 2 omega square minus 3j omega cube minus 2 omega raised to 4, and outside the bracket here is the minus jk. Now I will multiply inside the bracket with minus j, so it will become minus j minus 2j omega square. Now here jj will become j square, and j square, that is nothing but minus 1. So here minus j multiplied by minus 3j omega cube, that is plus 3j square omega cube. But here j square is nothing but minus 1, so we will write here minus 3 omega cube plus here minus j multiplied by 2 omega raised to 4, that is minus minus will become plus 2j omega raised to 4. So here I will take the imaginary part and real part separate. So this is the only real number. So I will take minus 3 omega cube as a separate part. Now if I take here minus j as a common, then it will become 1 plus 2 omega square minus 2 omega raised to 4. So I have to take this imaginary part is equal to 0. So 1 plus 2 omega square minus 2 omega raised to 4 is equal to 0. Now I will solve this. I will rewrite this as a omega square bracket square minus 2 plus 2 omega square plus 1 is equal to 0. Now here a square plus 2ab plus c, that is this is the form. So I will take this as a second order equation. Then how we can solve this? So I will get omega is equal to omega square. So here second order equation is for omega square. So it will become omega square is equal to minus b plus minus under root of 4ac, b square minus 4ac, sorry, minus b plus minus under root of b square minus 4ac divided by 2a. Now what is this abc? So this a is nothing but minus 2, b is nothing but 2, and c is 1. So I will take here minus b. So here this minus b, that is minus 2 plus minus under root of b square minus 4ac. So b is b square, that is 2 square 4 minus 4ac. So here a is minus 2. So 4 multiplied by 2, 8 multiplied by 1. So here this minus minus will become plus, plus 8 divided by 2a. So 2a is 2 multiplied by minus 2, that is minus 4. Calculated value of omega square is 1.36. So we will calculate omega, that is we will take square root. Omega is equal to 1.168. Now we will put this value of omega to calculate the magnitude. So this magnitude is already getting calculated in the step 1. So we will refer that formula, that is mod of gj omega hj omega is equal to. So I have put here directly values. Formula is in the step 1, k under root of 1 plus 4 1.366 divided by 1.168 under root of 1 plus 1.366 under root of 1 minus 1.366 square plus 1.366. So if we solve this, we will get the answer k 1.155. Now we will move for the Nyquist plot. So for that we will first take the polar plot. So polar plot is for section C1, and here is this polar plot. Now we will move for the inverse polar plot. Now this inverse polar plot is for section C3, and here is this plot. Now for this section C2, here magnitude is 0. So we will not draw this shape because magnitude is 0. And for section C4, magnitude is infinity. So here we have to join this C1 and C3 with this section C4 with magnitude infinity. So this is the required Nyquist plot. Now we have to find out this value of k to determine the stability of the system. So how to determine this? So for that, if we move for the number of open loop poles that we have already calculated, then we know that all these poles lies on the left hand side of the plane. So if we observe, this is the total S plane, then here is the right hand side of the plane and here is the left hand side of the plane. So we have already calculated the number of poles, that is S is equal to 0, S is equal to -1. So all these number of open loop poles lies on the left hand side of the plane. And if we move for the formula for stability, then formula is N is equal to P minus Z, where P is the number of open loop poles on the right hand side. So on right hand side there is no any number of open loop poles. So we can say that the value of P is equal to 0. Now what is the condition? Condition is system is to be stable. So for this stable system, if P is equal to 0, then we have to take this Z is equal to also 0, and then we will get this N is equal to 0. That means the Z should 0 for stability. So we can say that here Z we have to take for stability, Z should be 0, and we have to take this N is equal to 0. So when N is equal to 0 means what? That is N is the number of encirclements for the -1, 0 point. And where is the -1, 0 point here? So I will plot here -1, 0. And N is the number of encirclements. But for this system to be stable, here is the condition that when P is equal to 0, then Z should also equal to 0, and then 0 minus 0, that means we have to maintain this N is equal to 0. So what is the meaning of N? That is the number of encirclements for this -1, 0. But for this system to be stable, this -1, 0 point should not enclosed by the circle, and then only we will get N is equal to 0. So this -1, 0 should not be getting enclosed by the circle. That's why we can say that this -1, 0 should be outside this two-fold diagram or outside this whole circle. So how this can be maintained? So for that we have to determine at which value of K this required condition is getting fulfilled. So for that we can say that K multiplied by 1.155 should be less than 1. And then I will write here K should be less than 1 divided by 1.155. So K should be less than, so we have to calculate this, that is 1 divided by 1.155, that is 0.865. So this is the range of K for system to be stable. K should be less than 0.865, and this is the answer.